Welcome back, my friends. Let's go over simplifying rational expressions. Let's start with number 9. And you have here x's and y's and numbers. And we're just going to try to simplify this a little bit. But the first thing you should know is about these negatives here. So, for example, this y to the negative 3 right here. If it's a negative exponent, what you can do is you can just put it up top. You can just flip it from the denominator to the numerator. And you can do the same thing with the x cubed. I can take this x, or x to the negative 3 right here. I could just put this down below and write x cubed. But I'm actually not going to do that because there's another thing I can do, and that is I can combine it with this x to the 4th. And these together, you can just add the exponents together, and that's going to give me x to the 1. I'm just going to write x. Move it over here just a little bit. I'm just going to write x. And once I have that, I don't see any other x's there, so I do see the one on the bottom, but I'm going to leave that one alone just for now. I'll get to that in just a little bit. It's always good to not do too much at once. If you do too much at once, that's when you start getting errors and getting confused about things. So let's just leave that be. I think we're good with the x's right now. And then we have a 2 and a 3, right? We have this 3 right here, and we have this 2 right here. And let's just multiply them and give us a 6. And then we have the y's. So we have y to the 4th, we have y to the cube, we have another y here, and now we have another y cubed. So let's put all those together, and we're just going to add all those exponents. So this one here has a 1, and we're just going to add all those exponents together. So 4 plus 3 plus 1, that's 8, plus 3 is 11. So this is y to the 11th power. I'm just double checking, making sure I don't miss any letters. That sometimes happens. So just be careful and make sure you've accounted for every piece. And it appears that we have. So we're actually almost done. And this x right here will divide by this and give us 1. And this 6 and this 4 are both even, so we can divide them by 2. And we'll get a 3 here and a 2 here. And that means we can give our final answer, which is at the top is going to be 3y to the 11th. And the denominator is going to be 2. And that is it. And that's how you handle something like number 9. Let's get rid of some of these here, hopefully. Okay, next up, number 14. This looks like fun. So 14 here, we have negative exponents in the denominator. So just like before, I'm going to take these negative exponents and just put them into the top. Same thing with this y right here. This is going to be y squared. And this 4, do you see that 4 hiding right here? This 4 is going to cancel with one of these 4. It doesn't matter which one you pick, just whatever's convenient for you. And why don't we, so we actually don't have a denominator anymore. So in that case, the denominator is gone, and we just have to worry about what's left from the numerator. And what do we have? Well, we have, let's see, we have this x right here. We have another x cubed, and we have this x squared. Remember that the simple x has, this x right here has an exponent of 1. And so these here together, when you multiply them, you're just going to add all the exponents. That's going to give you x to the 6th. The y's, we have y to the 4th, y to the 4th, and y squared. Add those up, and you're going to get y to the 10th. And we do have a 4 left over. Let's not forget about that. And I'm trying to see what color I want to use. I'll stick with the red. So we have this 4 right here. It doesn't have anything to cancel it. There's no simplifying stuff. So we're just going to squeeze that in right here, and hopefully nobody cares that it's tightly packed. And call it a day. So that is the answer. Nice. Tricky, tricky, tricky. 17. Well, yes, I wanted to go over 17 because the answer is 1. Because this exponent right here. I don't care what mess you put in here. I really don't care what you put in there. If it's to the power of 0, it's 1. The only place where that might be a problem is it's 0 to the power of 0. But that has other philosophical implications, which we won't get into. And then now number 19. That's a nice one. That's a good request. So once again, if I see a power of 0, I'm just gonna erase it because it's just 1, and 1 will disappear in, well, basically any kind of operation except for plus and minus. So what do we have left? Well, we have this parentheses here that is squared. And I want to do that one first, because once I've resolved that, then I just have this whole parentheses here, like this whole thing right here will be nice and simplified. So let's square this y cubed, and I'm going to leave the x to the -5 as it is just for now. And I have my reasons for that. Oh, I'm sorry, it's not a negative x, it's just negative x to the 5th. Well, then it's fine the way it is. Times y to the 6th. Now let me use the color. Let me use y to the 6th. And this whole thing is cubed. So I hope you understand that these purple parentheses here are the same as the ones that I had on the previous part. And I think that's it for that. And then we distribute that 3. So you can just distribute this 3 to each of these. Please note that it's an odd exponent, and well, it wouldn't matter anyway because this negative, it's not negative x to the 5th. This is not the same thing. Well, in some ways it is. Negative x to the 5th. So it actually is the same thing for us, but not in terms of its presentation, because if it was something like negative x to the 4th, then that would not equal negative x to the 4th. And that's the whole property of odd and even functions, which we don't get to in IM3, not very much. So you can just ignore that. But there's a nice little extra tidbit if you care. So after you distribute that, all we really have is minus x to the 15th and times y, or just ignore the times, y to the 18th. And that's it for that one. 24. And then 29. 24. All right, we got some negative exponents here. And it's being multiplied. But, yeah, let's, this is interesting. So I'm going to re-express that first parentheses, this one right here. And I'm going to write this as minus x cubed divided by y cubed. Just because I don't like negative exponents, and so I want to get rid of them. And I'm just going to leave that as is for now. And similarly, I'm going to rewrite this thing here as negative. So I'm going to write -1, if you want, over x to the 4th y squared. And I want to point out it's not negative x that they're taking to the -4th power. It's just x that they're taking to the -4th power, and the negative stays in front. So that's why the negative doesn't go away when you take it to an even exponent. Well, because it's not being taken to an even exponent, because it's just the x that's getting that negative exponent. So if it was the negative as well, it would have to put parentheses around it, but it didn't, so we're good. Next up is I'm going to simplify. Yes, I'm aware of the clock. I'm going to simplify this right here. I'm going to distribute this 2, and it's going to go to each one because you're squaring it. So this is going to give me, well, and now that it's negative x cubed times negative x cubed, that is just x to the 6th over y to the 6th. And this is -1, right? So we have negative And then we also have here x to the 4th y squared. And that, my friends, will simply become negative x to the squared over y to the 8th. And that's presumably all we have time for. This is just 1 over all of that. So this is 1 over u cubed v to the 4th v to the 15. So in other words, 1 over u cubed v to the 19. Thank you very much, everyone. Please like, share, and subscribe. Thank you very much.